Java is going to be our programming language for today. Okay, so yep, let's get started. So in terms of agenda, what are the things that we are going to cover? So let me just put things down. The number one is what exactly is R like. Okay, so I would say intro to threads. Okay, so introduction to threads. Then we'll learn about hello world of Java threads. Why we'll go through this hello world, I'll talk about it. I know many of you would already be knowing it, but this is very, very important. The reason is since GDK 21, we have got significant changes that has come within the Java and related to multi-threading and concurrency. So that's the reason we are gonna look at this aspect as well, right? The next, we'll talk about the threading types. Okay, so threading types, their life cycles. Then we'll talk about priority, right? So basically you will be introduced to different type of threads that is supported in Java. And we'll talk about what are the life cycles and how we can visualize it, how to do the multi-threaded program, right? So sorry, a single-threaded program so far. Then we'll introduce you to what exactly is multi-threading, okay? Then, okay, and then we'll talk about, I think later part of the section we'll talk about. Then we'll also talk about the executor service. And before that, we'll talk about concurrency. And we'll take a look at the practical examples. For example, we'll see some of the locking mechanisms also we'll see, okay? Some of the locking mechanisms. Or you can say that synchronization mechanism, okay? Mechanism, all right? And next, I think, and when we'll see some of the practical examples of threads, okay? So just to set the context, right? So we'll have mix of theoretical as well as practical examples. We'll see that. And we'll understand at least from the basics, at least from the standpoint of looking at any multi-threaded program, how they're running, how we can actually use the multi-threading logic while writing any applications. So we are going to see that. And the levels are going to be, again, it will cover basics, intermediate, and some level of advanced. I will not go the dig deep of the advanced level concepts for example, there are concepts like semaphores. There are concepts like the cyclic barriers and so on. So basically, we'll definitely provide you the reading materials for those topics from those topics. But yep, this session covers right from the scratch up to the good understanding of how you can actually go and implement the threads. All right. So before that, this is brief about me. I have a total of 10 plus years of software industry experience. I've done my master's from IIT Guwahati, and I've been a software engineer. My last role is with Oracle Cloud. I was working there as a cloud engineer. Before that, I've been working with Informatica. I'm an Oracle certified professional, and I do have an MLOps certified from IIC Bangalore. All right. Let's get started. Let's start with a simple Java program. How exactly a simple Java program gets executed on our JVM on our machine. Okay, so any program that you write, irrespective of the language, any program that you're gonna write, what happens is that your program, let's say this is you're gonna write the program in a sum file that will be called as source file, and that file, that program will get compiled based on the language. They will get compiled. Now, this compiled program can get executed. So you will have a source program, you will get them compiled, and then you can get them executed. The compiled program, you will start getting executed. Now, execution of the program happens within a CPU. Execution of, in fact, any program running on your computer, in fact, any software running on your computer, execution happens on the CPU. All right, clear? Now, let's try to understand the CPU internals, and then that will help us resemble how exactly the threads are corresponding to it, how exactly threads get executed on the CPU core. So if we take a look at the CPUs, what it has is, it has different cores. So CPUs are comprised of several cores. Now, here, the blue one that I'm talking about, these are the cores present on the CPU, Central Processing Unit of the computer. Now, here we talked about, so the number of cores your CPU has, based on that, its name gets, right? It gets its name, okay? So for example, here we have 4 core, and we can call this as quad core. In general word, we call it as quad core processor, okay? All right. Similarly, for hexacore, it will be 6, for octa-core, it will be 8, and so on. Now, what these core belongs to, what exactly the meaning of or the uses of these cores, okay? Now, these cores are used to execute the threads, okay? So basically, these cores are used to execute the threads. Now, till now, I haven't introduced you to what exactly is a thread. So just bear with me. Understand that, or assume that for now, that okay, thread is I would say, the lightweight program that gets executed on a CPU core. Now, each CPU core, so ultimately on the CPU core, what exactly gets executed? So we can call it as instructions of the threads, instructions, okay? Instructions of the threads get executed, okay? Now, what exactly these instructions are? Instructions are, I would say, for example, I'll give you some example of instructions. Imagine I want to add 2 numbers. Imagine I want to add 2 numbers. Now think of it, how CPU does the addition of 2 numbers. So CPU also have, apart from cores, they also have some sort of registers. They do have some sort of registers. You can call it as R1, you can call it as R2. Okay. Now, any operations that we perform, for example, the very simplest one I took is the addition. The addition of 2 numbers. So first, those numbers has to be stored within these registers, and then only the operation can be performed. So remember, any operation that CPU is doing, the data needs to be loaded within the CPU registers, then only it will perform the operations. Okay. Now, in order to perform the operations, what it needs is, it needs the instructions. Now, if I'm taking the example of adding 2 numbers, the instructions of somehow will get generated like add. So add is a instruction set. Okay. You can say that add R1, okay, to R2. Okay. So it's like the instructions are written like this. Okay. So the operation type and the operands based on the operation type. So if this is a binary operator, so for example, add is a binary operator, you are going to give the operands on which the operation needs to be performed. So here I'm giving R1 and R2. These are the registers. Okay. So just for now, just assume this low level instructions. Okay. Now, By just giving this instruction set, what CPU is doing is, imagine R2 has, let's say 5, R1 has 10. So what CPU is doing is, it is adding the value of R1 and R2 and storing it into R1. So whenever we keep it, the leftmost one, they also become the target of it. So as a result of this instruction execution, what will happen is your R1 will get stored as 15 and R2 will remain as 5. There are other instruction types, for example, load. So how will CPU register? This register will get the value of 10. So there is a load instructions, there is a store instructions, and so on. There are a lot of instruction set that are present for the CPU. Now, why we need to care about all this? So any program that is getting executed, think of it, for example, on your computer, if you are, let's say, opening a Microsoft Word, that is also software that is also having comprised of several programs, that is comprised of several programs. Now those programs will get executed in some threads. Those programs will get executed in some thread. That thread will have the set of executables, set of instructions, and those instructions one by one, they will get executed on some CPU core. And that's why we are able to perform operations. For example, the example of Microsoft Word, any write that you are doing, that write needs to be processed. Any CPU, basically keyboard input that you are giving, they needs to be processed by the CPU. So any instructions or any word that you are typing on your Microsoft Word, that needs to be read from the keyboard, that needs to be processed somewhere in the memory, and then that needs to be stored and displayed on the file. Okay, so the whole point is every operations that you perform, CPU has to get involved, and CPU has cores. It can only execute some threads. It can only execute some threads. Clear so far? Is it clear so far? Why the thread comes? We'll talk about it, but in a computer system, we have got CPUs who actually execute the thread. Am I clear, everyone? Yes, no? Yes, no? Let's keep this session interactive. Okay. All right. Okay. So moving on, coming back to our simple Java program, Okay. And before coming back to the simple Java program, let's just go through what exactly is the single processor, basically a single threaded system or multi-threaded system. So it could be that a CPU only has one core. CPU only has one core. So we call it as single threaded system. We call it as single threaded system. Now, how different program will get executed on this single threaded system? So different program will have different sort of threads. Different program will have their own internal threads. Imagine they have program one has two threads. Program two has, imagine, one thread. Program three has, imagine, four threads now. P2 and P3. Now, in order to get these programs executed on single threaded system, what needs to happen? Thread scheduler. So in operating system, there is something called as thread scheduler, who is responsible for scheduling the thread. Okay, who is responsible for scheduling the thread. Now, on a single threaded system, what will happen? Each thread, imagine for thread T1 of P1, they will get scheduled first. What will happen to other threads? Other threads will wait until this T1, P1 of T1, P1, T1 completes the execution. All other threads will wait. Once P1, T1 comes out, completes its execution, what will happen? Maybe T1 of P2 gets scheduled. So again, which thread will get scheduled next on your CPU? That is again decided by thread scheduler. That is again decided by thread scheduler. There is something called as thread scheduler, okay, which is responsible for scheduling threads for execution. Okay, now, so thread scheduler is responsible for scheduling threads for execution. So let's say the sequences are in a single threaded system. Your sequences could be that P1, T1 got executed first. P1. Then P2, T1 got executed next. Then P3, T1 got executed. Then P3, T2 got executed, and so on. The order could be anything. It will be decided by thread scheduler. Okay. So in a single threaded system, even if you write multi-threaded program, your program is gonna run sequentially. Your program is gonna run sequentially. What does sequential mean? It will be running one after another, and so on. Okay. So, and what this mode of program execution, we call it as, sorry, CPU sharing. We call this as CPU sharing. So a single threaded system, on a single threaded system, multi-threaded program will just share the CPUs. You are not gonna see the true parallelism. You cannot say that on a single threaded system, all these programs are running in parallel. So you cannot say that. That cannot happen, because in order to get executed, any program to get executed, its threads needs to be running. Now we know that there is only one place where execution can happen, and that's why they has to be lined up. Each program will get sequenced, and then they will get executed. We call it as CPU sharing. Here, what is happening? A single CPU is being shared by all the processes. Okay. So this was the old, I would say, old processors, which used to be a single processor, right, threaded system. Now, or actually, we can also call it a single core system. Okay. Then comes the multi-core system. What exactly multi-core system does? It has different cores. So the four core that we saw the examples, that is a multi-core system. This is a multi-core system. Now this multi-core system can take the true advantage of your parallel, programs having different threads. Okay, so this multi-core system can take true advantage of. Here what can happen is, imagine your P1 T1 gets scheduled first, then on this core, then P1 T2 got scheduled here, or maybe P2 T1 got scheduled, then P3 and so on. So other threads, other core is remaining idle. That's completely okay. Okay, now what is happening here is, on a multi-core machine, if you have a program which is multi-threaded, if you have a program which has multiple threads, they can take the true advantage of the multi-core machines. So if you are having single threaded program, on a multi-core machine, what will happen? They cannot. So if you have a single threaded program, imagine you have all of the programs. Imagine program 5, it just has one thread. So what will happen? Any core that it got, imagine it got the core 4, any core that it will got, it needs to execute its instructions sequentially. So it could not take the complete advantage of multi-core machines. It could not take the complete advantage of multi-core machines. So, okay, why we are talking about all this? The reason for that is, it is compulsory to understand what is the difference between single core machines versus multi-core machines to understand the advantages of multi-threaded system. Okay, so that's why we are going through this. So just have patience, and then we'll go through it. Okay. So what we are talking about is the processes, okay, the multi-core machines. We have got a single threaded program. What will happen? It can't fully utilize the multi-core systems. Okay. Multi-core, core as in core belongs to, you can core, core and threads are actually interchangeably, it can be used, okay, but not the Java threads. We'll talk about it. Java threads are totally different, okay, and actually it has slightly got modified as well. So we'll look at that. Okay, so single-threaded program cannot fully utilize the multi-core systems, but multi-threaded programs, actually they can fully utilize the multi-core systems. Okay. Okay, in the previous slide, what we saw, multi-threaded program cannot utilize or is actually if inefficient on a single core machine. Okay, so you need to keep that in mind. Okay, now coming to today, in today's world, none of the programs or none of the software system are single threaded. In today's world, none of the software system are single threaded. Okay. All right. Okay. And none of the modern computers are single core. All right. In fact, even you go and try to buy your smartwatch, there is a processor that is fit within your smartwatch, and that processor also are having multi cores, at least two cores, dual core or yeah, dual core at least they are, or maybe in some cases quad core. Okay, so any system, any computer systems that you talk about today, modern computer system, they are actually multi-core machines, and hence the softwares required to completely utilize the multi-core capabilities are actually the multi-threaded programs. Okay, clear so far? Yes, give me a yes. Or is it right? Is it boring? Do you find this boring? Yes, no? Okay, now let's talk about, okay, there is a term called multitasking. What exactly do we mean by multitasking? So it allows two or more entities to run simultaneously. That's what we call it as multitasking. Here we are talking about entities. We are not talking about two threads. We are just talking about two entities. Imagine you are writing something as well as you are sipping coffee, which means you are doing multitasking. You are watching movie and you are having popcorns. Again, you are doing multitasking, and so on. There are a lot of different. So the whole idea is you are doing two or more tasks, right, simultaneously, and that's what we call it as multitasking. Now, in software world, the multitasking is achieved by two means. You can do the multitasking, the process based and the or the thread based. Okay, so multitasking can be done using process based, as in creating different processes which can run simultaneously, that is also multitasking, or creating two different threads and getting the task executed, that is also a multitasking. So what we are saying is it is a thread based as well as the process based. Now, what exactly is a process based? Let's understand that. Okay, now it allows two or more programs to run concurrently. What do we mean by concurrently? You can say that simultaneously. Okay, So it is doing that, okay, both the programs, you have both the programs and both of them are running in parallel. For example, you are running a Java compiler on your machine while uh, running the text editor or visiting website. So this is the process example of process-based multitasking. You are just browsing your web, you are having your server running on your computer, maybe a Java program, or maybe some server running, Tomcat server or whatever, right? And at the same time, you have some Word document open, that some text editor open, some other software, right? A lot of other softwares that are open. So it is an example of the process-based multitasking. Clear so far? Clear so far? Yes? Yes. Now, what exactly are the thread-based? What exactly are thread-based multitasking? A single program can perform two or more tasks simultaneously. So here we are talking about a single program. Within a program, let's say I just opened a software. I'm just trying to run a particular program. There are two or more things that is happening just within that particular program. And that's what we call it as thread-based multitasking. Okay. For example, take the example of text editor. While writing, so we have got a text editor. While writing, I wrote. So at the same time, it is doing the right formatting of the text. Some text it is formatting, some space it adds, some indentation it adds, and so on. So what is happening? There is a different thread that is running and adjusting the text, that is doing the formatting, that is doing the spell check. Okay, so same time that is printing or doing spell check. Okay, so this is the simplest example of the thread-based multitasking. Okay, clear so far? Yes, yes, no. Clear so far? Come on. I need right the answers. Okay, all right. So what exactly is multi-threaded programming now? What exactly do we mean by multi-threaded programming? So we are calling it as thread-based multitasking can be achieved using multi-threaded programming, or we also call it as multi-threading. Okay, clear? Thread-based multitasking can be achieved using multi-threaded programming, or in other words, multi-threaded programming, we also call it as multi-threading. Very simple. Now let's take a look at the some of the more basics of thread. So what exactly is the thread? Okay, so we are talking about that. Okay, it has to be the thread based. Okay, so for example, the text editor example, we can call this as text editor is a multi-threaded program. Text editor is a multi-threaded program. All right, text editor is a multi-threaded program. Clear? Now, what exactly is a thread? It is the smallest unit of execution. We already saw it is the smallest unit of execution, and execution on any computer will happen on CPU, Cool. It is also lightweight. Why exactly we call it as lightweight? We will understand it. Okay. But first, let's go and understand a process. We'll understand why it is a lightweight, but this is a lightweight. Okay. You can call it as your process is also an executable instance. A thread is also an executable instance. Okay. Now, why we are calling it as lightweight? Why we are calling thread as a lightweight, not the process? Remember, your thread, okay, cannot reside without process. Thread can't exist without a process. Keep that in mind. Do you agree? Thread cannot exist without a process. So first, in your computer system, a process will get created. Then within that process, you will have different threads running, and those threads will get executed on your CPU. Yes? All right. Now threads of a program, what it does is it shares the same address space. Why? Because this is your process. This is your process. Now, in order to get this process executed, they need some sort of address space. They need a place where they want their code to be copied, their instruction set to be copied, and hence you call it as address space. So all the threads will share the same address space, and this address space will be of the process. This address space will be of the process. And then right, because it shares the same heavyweight process. Okay. Clear? Now, there is a term that is called as context switch. So what is happening? Let's take the multi-core system right as an example. In multi-core machines, what happens? Once a thread completes the execution, or thread scheduler actually uses an algorithm that is called as round robin algorithm for thread scheduling. What that round robin algorithm does is it allocates some specified amount of time for every thread. And within that a specified amount of time, let's say T naught, the thread should get executed. Once that T naught is achieved, once that time is completed, what happens? It does a context switch. It allows some other thread for the same time to get and go and do the execution. So what happens? This thread needs to be stored and persisted somewhere. This thread needs to be saved somewhere. Okay. Why saving is required? Because next time when its turn come, it will again go and restore that thread and then resume the execution. That's how the actual execution happens within the CPU. Okay, so what we are saying is in your multi-core machines, a thread only gets a specified time slice. We call it as a time quantum. Okay, time quanta or time quantum. Okay, it is typically in nanoseconds. Okay, so it's like each thread will get a specified time. Once that time is passed, this will get wrapped up, new thread will come for execution, then a new thread will come. So basically thread actually themselves form a particular queue so that each thread will get chance to get executed. Okay, each thread will get its own turn to get executed on the CPU. We call it as fair scheduling. So this way we call it as fair scheduling. Okay, so that each, and this is again the scheduler, right? The thread scheduling algorithm. Okay. Okay. So basically thread scheduler uses this to schedule each threads on your CPU. And what it does is it gives you, okay, you have just 2 minutes. Imagine you are having imagine, right? In old era, there used to be a telephone booth. Okay. Telephone booth. There, people used to get a specified time. Okay, go into that and just make your call or do whatever you want to do. Right, make a call. Just complete the talk, and then you come out. Then the next person that is standing here, they will get the chance. They will go and talk about. They will go and do the things. Same happens at the ATM machine, and all these are done just to ensure that everybody gets a time, right, a CPU time or a resource time, so that they are not feeling starved, they are not feeling left alone, right? So they are not deprived of the resources. So the whole idea is every time the each thread, once its time completes, that thread's state needs to be saved somewhere, and that this process of saving the thread state and restoring back, this is called as restoring back the state of different thread, is called the context switch. Okay, this is called as context switch in terms of the thread scheduling. So what it says is that context switch of two threads is of very low cost. So saving the state, storing it somewhere, and then restoring some different thread state back onto the CPU and then resume the execution for the again specified duration is of very low cost. That's what is context switch. Okay. Is this clear to all? Is this clear to all? Yes, no? Okay, the context switch. Okay, I'll just go and repeat that. Uh, context switch is saving the state of a thread. So just understand this. CPU has a scheduling algorithm. It has a mechanism so that every process and their threads, they get uniform CPU time. They get the same time slice for executing their threads. So what happens? A thread of a particular process, they will get scheduled on the CPU, and as soon as the time completes, the state of the thread from the CPU will get stored somewhere. They will get stored to the some place, some memory, and the new thread come back and start executing on the same CPU core. And this phenomena, the process of saving the state of the current thread and resuming the execution of the next thread, is called as context switch. It is removing and then bringing something else. Okay, so that's what is called as context switch. And in the case of threads, this context switch is of very low cost. All right, now we'll move on. For the process, again, this is a runtime entity. You can call it as program in execution, and simply a group of threads that execute in the same shared environment. That's what we call it as process. Okay. So what process are comprised of? They can be of single threaded and they can be of multi-threaded. Okay. And multi-threaded, we already know what it is. Okay. Now, again, this is some information about process like heavyweight task. It requires separate address space, and inter-process communication is expensive and limited. This is important if you want to understand inter-process communication. Imagine you have two process running. Okay, two process one and two process two. Because they have their own different address space. They have different address space. Communication between two is not obvious. Communication between two is very, very expensive because they do not share anything. Two different processes, they don't share anything. So what needs to be done? They need to have some shared mechanism where one process is going to write and then next process is going to read. And that's what, or right, somewhere it needs to write some shared environment. You can call this as shared environment. Okay. And where some thread needs to be writing here, and then another thread is going to read from there. And that's how two processes communicate. Okay. Communication between two processes, remember, is not an easy process. All right. There are different IPC mechanisms that is used. One of them is, in Java, one of them is RMI. Okay. One of them is RMI. Okay. Now, the whole idea is it is expensive and limited. But if we talk about the right, so for threads, these two actually share the same address space, which means they can access the same memory locations either from T1 or from T3 or from T4. So the based on the way we write the program, it can share the same variable, same address space, and that's why it is able to communicate. One thread is able to pass the information to the next thread, and that's what we call it as inter-thread. We can call this as inter-thread communication. For threads are of very low cost. It is very, very fast. All right. Now, okay. So, just to brief on the single threaded system, we already talked about it. What happens is a single thread keeps on running on infinite loop. It waits for some queue. And what it does is it keeps on polling as in checking, okay, hey, do I have some task available to do? If it is, I'm gonna just doing that task. That's it. I'm gonna just doing that task, and that's how single threaded uh, program or single threaded system works. Okay. Now, as I said, it uses polling to decide what to do next, right? So that's how single threaded system works. As opposed to, okay. For example, let's say you have got event queue. Within that, let's say you got a signal that a network file is ready to be read. Imagine you have got a single threaded system, and on the queue, you got something that, okay, some network file needs to be read. What will you do? What will you do? You will just transfer your control to just read from the file. So once you got this, you will do the polling. You will find there is something to be done. Then this control is transferred completely to read from the network. And at this point, while the file is being read from the network, if something arrives at this place, nobody is there to check. And that's the disadvantage of single threaded system. So unless the single threaded system completes the execution of what it is doing, it cannot do something else. All right, we explained it. Okay. Now, if a thread blocks, okay, maybe some suspends execution. So what is the okay, blocking of the thread? We'll talk about the states. What are the different states of the thread? But imagine if it gets blocked, which means it is not allowed to do something. Blocking of thread happens when it is waiting for some resources, and right, because it is waiting for some resources, entire program stops running. Your complete single threaded system is paused because it is waiting for some messages or something to happen, the network file to be read. And imagine the network gets disconnected and there is no handling mechanism. Your system is hang forever. All right. Now, let's talk about what exactly is Java's thread model. Okay, so in Java, which thread model is used in Java? Okay, so Java uses multi-threading to enable the entire environment. So it uses multi-threading to enable the entire environment to be asynchronous. Now, I want you to list how many things happen when you just start executing a Java program. I want everyone, please respond. How many things happen when you start executing your Java program? Your JVM is spawned, right? Then all the address space is initialized. Then your class loader system is running. And then actually it starts loading the very first class or the main class that you provided. Okay, then it loads the main class. Then once the main class start execution, it class loader also tries to load meanwhile the other classes that was referred within the main class. So all sort of things are happening in parallel. All of them are happening asynchronously. What is asynchronously? It is like two things are happening without waiting on others. So it's like one thing is initiated, then the next thing is running, and so on. So there are three different things that got initiated, and they don't need to wait upon each other. Okay, so Java, okay, so what it does is it enables the entire environment to be asynchronous. Now the good part about Java is it works on both type of systems, that is single core as well as multi-core. Both type of systems it works. Keep that in mind. Single core machines and multi-core machines, both type of systems it works. Imagine how powerful right these designers of Java was. Okay, so the contributors of Java, how powerful they were. They just thought, how can this entire software run on a single core machine, and how can run efficiently on multi-core machines? Okay, now what it does on a single core machines, so two or more threads, it just do not run at the same time, but just ideal CPU time is utilized. We can call it as CPU is shared. Okay. Okay. Now in two or more threads, they execute simultaneously, right? And they improve, right, program efficiency and actually increase the speed of the operation. So that's why multi-core machines, your Java program will run faster, because in order to run your program, the Java, the Java systems, JRE systems, they need to do a lot of things in parallel. In fact, at the same time, you're just doing object creation, all sort of things, right? The class loading is happening in parallel. At the same time, your garbage collection is running. So all sort of things are happening in parallel asynchronously. And that's how the Java's thread model has been. Okay. Clear so far? Clear so far? Yes, no? All right. Now in Java, okay. Actually, let's do that. Some basic program first. Okay. So basic basic Java program. Let's take a look at why I'm talking about the uh, a single threaded program. Why I'm talking about that. Okay. So imagine. I'm gonna just share my screen. Allow 1, 2. Okay, hope my screen is visible. What I'm doing is, let's say I've got this main method, that's fine. Let's say I want to just add. Is my screen visible yet? No, yes, no, yes, right. Can you please confirm someone? All right. So what I'm saying is, imagine I'm just doing addition of two numbers, as I said, and let's say I just want to do okay. So this actually int and int b. Okay. Or actually, yeah. Okay. So executing. Okay, let me just get the thread name. Okay, so I'm just want to thread name. Okay, so we'll add that thread name, and the thread names are like, you can call thread dot current thread. Okay, and then dot get name. So this gives you the thread name who is actually gonna execute this particular method. Okay, now what I'm gonna do is return this a plus b. That's it. And what I'm doing here is I'm just gonna print same thing. Right, executing main thread name. All right. Okay. So, all right. Now what we did is I'm gonna call add 10, 5. And after that, I'm just executing, right? All right. All right. Fair enough. Execution complete. Okay, so what we are gonna see is not just this, or let's say now what will happen? This is a very simple, very simple program. I'm just gonna run this program. What we'll get is we will get the thread name as main. Okay, so basically what is happening now? What is happening? Whenever you are running your program, there is already a thread named as main that is already created for you. Who created that thread? I did not create. Did we create any thread here? No, right? We just wrote the program here. Who created this thread? Now this thread was created by JVM. This thread was created by JVM. Now let's take a look at the IDs of this guy. Okay. Okay. Now let's take a look at of the okay. Now the IDE of this thread is actually one. Okay, keep this ID in mind because I'm gonna show you something. Okay, once we talk about the multi-threaded program, we will see what are the okay different type of threads, different threads that got created. So that's why. So main is the first thread that got created, and that's why the ID that it got is one. Again, remember this ID is relative to the Java process. There could be thousands of other threads running on my laptop, but this ID, you should remember that this belongs to or relative to just the Java process because this thread only knows the Java program that is being executed. Is it clear so far? Okay, so what we are saying is any simple program, what happens is everything will get executed by your main thread unless you go and create something. Now, main thread is something that you did not create. So who created the main thread? It is your JVM who created the main thread. One more thing, whenever you run any Java program, always keep that in mind. There will be one JVM that will be launched. There will be one JVM that will be launched for that specific execution. So let's say if I'm executing this 5 times, let's say I executed it 1, 2, 3, right? Whatever. How many times? So that many times the JVM is getting launched, the main thread is getting created, my method is getting executed, and once my method execution is complete, the main thread gets terminated and then process gets terminated. That's how it happens. Is it clear, everyone? Is it clear, everyone? Yes, no. Come on, I need answers. If it is too basic for you, just provide me that. I'm gonna right level that up. Okay. But just I'm just keeping right a balanced approach here. Okay. Okay. How is it so far? Is it like you're finding it too boring? Everyone, how is it so far? Is it too simple or okay? Now let's understand the Java thread model. So what Java does is the main program that we did, what it does is main thread. So in fact, any thread that Java creates, they get corresponding operating system threads. They get mapped to corresponding operating system threads. And this mapping is always your 1-to-1. This mapping is always 1-to-1. Okay. All right. What we are saying is any threads that you create in your program, they get 1-to-1 mapped with the operating system threads. This is operating system threads. Okay. All right. Now that operating system thread actually limits the number of threads that you can create within a particular within a particular process or for a particular Java program. Okay, so before JDK 21 till JDK 21, number of threads that is created in your Java program has to be limited. You cannot create unlimited Java threads from your program. Okay, keep that in mind because each Java threads needs to be mapped to its own operating system threads, and operating system knows how many threads can get executed on its system. Okay, because each thread that you create that takes its own memory. Imagine you wrote a program to create 1,000,000 threads. What will happen? Your operating system will not allow that. Your program will crash. Okay, if you know the JVM's understanding, if you have some of the JVM's basic understanding, what happens is, for every thread, there is a program counter, right? The PC PC that gets created. Okay, so PC is a memory location within the JVM that gets allocated for every thread that you are creating. Okay, so if within your program, if somebody asks you that, hey, can I go and create million threads in Java? The answer to that question prior to JDK1 used to be no, that cannot be done. My program will crash, my JVM will crash, and that's it. The reason for that is each thread takes some amount of memory. Each, right, that memory needs to be allocated within the JVM. By default, the JVM has right, gets created with the fixed size of the memory. Now, if I'm creating the million threads, the memory required to create those million threads, if that goes beyond the JVM's allocated memory, my JVM will crash, and that's the right, that's the rule of thumb that used to happen before JDK 21. But after the arrival of JDK 21, there is something right, something that got changed. What that change is, let's go and take a look at it. Okay, so in general, operating systems manages some of the system threads. So whatever we are calling it as, you consider, or you can call this as system threads. So operating system manages system threads. Now, Java executes processes using something called as platform thread. So each threads that you are seeing here, they are called it as platform threads. Before 21, there was no name. They were just threads. But after 21, they are given as a name as platform threads. Now, each platform thread has one-to-one mapping with the operating system threads, which limits the number of threads you can create from a Java program. All right, clear, everyone? Now, let's take a look at this picture. This is your Java program. It has some shared memory. These are nothing but your shared variables that you are sharing with the threads. So you have got platform threads, and they will have one-to-one mapping with the operating system threads, and then OS thread scheduler will get this thread scheduled to either one of the CPU. And that's how it happens. All right. Is it clear so far? Is it clear so far? Yes, no? Yes, no? Come on. Is this been clear? Okay. Now, in 21, platform threads got divided. Okay, so basically these platform threads, which is created by JVM, this is created by JVM. Even if I write the program, to create a new thread. Who creates that thread? So that thread is created by JVM, because JVM is the one, if we saw, who created the main thread also. Okay, so these platform threads are actually divided in two parts. One is the system threads, another is the user thread. Okay, one is the system thread, another is the user thread. Again, this is just the logical separation. What I'm saying is, this is just the logical separation of the threads. Again, this is created by the JVM. This runs in the background of the Java applications. For example, the garbage collector, for example, the class loader, for example, right? There are a lot of other things. So it's like all these are part of the system threads, and whatever thread that we created, they are treated as a user thread. Okay. Now, each thread performs a work. Okay, performs a work, and that unit of work we call it as task. Okay, and what it says is that a thread can complete multiple independent tasks, but only one tasks at a time. So what thread does is, the thread that is present in Java, they can execute multiple tasks. So it is a thread, it can go and execute multiple tasks. Let's see this from the analogy. Okay. Now, imagine you went to a restaurant. Okay. Imagine you went to a restaurant and you got a personal butler assigned. Butler, you can call it as waiter. Okay. Now, his job is to receive the request from only from you and go and get the request and serve the request for you. And till the time you're not adding or putting any requests, he just has to wait there. That's it. So platform threads were like that. Whenever you create some threads in Java, they were like that. It's kind of, you are reserving a personal butler at your restaurant, and imagine all different processes started doing that, how inefficient it would have been. So that's why these platform threads are actually inefficient. It's not the best use of time. It's not the best use of butler's time, because during the time it is waiting, what it can do is it should be allowed to serve someone else. Agree? It should be allowed to serve someone else, right? So that's why these platform threads are like a personal butler. You create it and it is reserved for you, and he will only take instructions from you, and just like that, right? So whatever program used to create a platform thread, unless you add a task, it is not gonna execute some different task. So only the order that you are placing, only that order will be served by these platform threads. Is it clear to all of you? Is it clear to all of you? Platform threads are like your personal butler. Now there is a new concept that has come. In JDK 21, there is a new concept of virtual threads that has come. Now, what these virtual threads are, okay? So virtual threads are like a server. Sorry, virtual threads are like a different table. So it's like each of them that you are seeing here, they are the virtual threads, okay? And there will be someone who will go and serve these threads. Okay, so there will be a server, and in general we call it as courier threads. Okay, and what exactly these threads are, they are just gonna serve each thread. So it's like whenever you placed some order, right? Whenever virtual threads placed some order, whenever some task is submitted to the virtual threads, what it does, there will be a courier thread that will be assigned to this virtual thread, and then that courier thread will be responsible for getting the task executed for this virtual thread. For this order, whatever task that you placed, whatever order that you, for this table, whatever order that you placed, that the responsibility of this guy, this is your server, their responsibility is to go and bring that order to you. They will serve, and that's it. If somebody else or this table places an order, they will go and serve on that particular table. Okay, so that's how the virtual threads was arrived. That's why the virtual threads are created. The reason for that is you can create as many virtual threads as you want, unless there is a task that is submitted to these virtual threads. Execution is not going to happen. These can exist on its own. Okay, so these can exist on its own. Okay, exists on its own. Okay, and by bringing this mechanism, we are now making good use of this courier thread or the server that we are talking about. Yes, because now this waiter, as a restaurant owner, I just need to have few waiters who can serve, right, individual tables at the same time. But imagine I would have right had this facility where I will have each waiter assigned for each individual tables. How many, right, personal butlers I would need to kind of, right, hire. Think of it, right? So it's like for everyone who needs their own individual butlers, I need to hire as many butlers as there are number of tables, correct? So instead of that, what we did, we just introduced the concept of virtual threads. Now once you come to this thread, once you go and create this virtual threads, you will no longer get your personal butler assigned. Instead, once you submit the task, once you place an order, then only there will be a server who will come back. There will be a butler that who will come back, receives your order. They will go and get that order for you, and then they will serve your order. That's it. Once the order is served, the next order that you are gonna place, you might get assigned a different butler. He will come, receive the order, he will take the order, bring it back to you, and that's it. His job is done. He's now free to do some other tasks. Is it clear for you why the virtual threads are introduced? Is it clear for you? All right. All right. How's been session so far? I mean, is it okay, good, bad? You can just answer. Not bad. Okay. Thank you. Okay, so virtual threads, let's talk about some of the understanding, right? So it is less resource intensive than the platform thread. So the career thread that I'm talking about, for understanding, you can consider them as platform thread, but there are some difference, okay? You can consider them as platform thread. So now, what with the introduction of this architecture, what JVM did, JVM just made entire platform lightweight. It gave you an option whether you want to hire a personal butler or you want to go through with the virtual thread, which means somebody will come and get your order and you will get the order placed, right? So this system is not, I would say, mandated for all, okay? The system of every table needs to be served by a common butler. This is not mandated for all. User has a choice. You go to the table, you can ask them, you can request them, hey, I want my personal butler. If you request that, which means you are paying for that, and you will be ensured that only that butler will serve you and it cannot serve anyone else. So you can follow either approach. So as a developer, I am given a choice whether I want to create threads of virtual thread type or a platform thread type. Platform threads are nothing but your personal butler, and virtual threads are nothing but your common butler. Okay. Okay, you will get a common butler who will come and serve you. Okay, so now it says that it makes good choices for. So in what all scenarios we can use this? So imagine in the platform threads or in a generic thread that we all know, imagine we created a thread and from that thread we are waiting for some IO. So after that we did some operation and this is just waiting for IO. So what will happen? This thread will remain in blocked state. They will remain in blocked state, and this is not the good use for. And we know that there is a corresponding operating system threads that is there, correct? So this is again, this also will remain in blocked state, correct? So the whole idea is, if you are creating some platform thread and using it for maybe somewhere some resources which needs to wait, okay, so that's not the good use of platform threads, and hence in such scenarios we should be using the virtual threads. So virtual threads are right, make good choices when your thread need to do the IO wait, or when you want to wait for some other network resources, in which basically wherever your thread can go into the blocked state. Okay, Now, again, this is obvious. Every time virtual thread is ready to run, which means some order needs to be placed. It waits for some butler, personal butler to, sorry, common butler to be available, and then only it will be able to start execution, right? So then only the task will start getting executed. So again, keep that in mind. Virtual thread is nothing but you are having a common butler who will come and serve you. That's it. Now, let's take a look at the diagrammatically. We had the shared variables. I can have a career thread. In fact, I can have some platform threads as well, PT. Okay. Now there are several number of virtual threads. And whenever some task is submitted to this thread, what will happen? The virtual thread will receive a career thread, and then the career thread will have one-to-one mapping with the OS thread, and then it will get scheduled by the thread scheduler on this CPU. Okay. So the whole idea is we now can technically create any number of virtual threads from our program. All right. Now the questions would be, how do we create threads? So we are gonna see that. Okay. These are just FYI. Okay. So from the code point of view, I mean, for in documentation, right? So these are actually referenced as a platform thread. Okay, just to convey that it runs on the OS. But if you go and look at the code, it is slightly different. Okay, now virtual threads are again scheduled and managed by JVM. So just to look at it, who will schedule the virtual thread to a carrier thread? So that is the job of JVM, who will ensure that your virtual thread gets scheduled to a career thread. All right, now let's see how we can go and create the thread. So we, all of us know that, okay, there are only two legacy ways to create a thread. You go and implement Runnable. So this is an interface. Implement Runnable, or you go and extend the thread class. Okay. And then you are gonna implement. So whenever you go and implement it, you need to go and define the override the run method, run method. And in this case also, you need to go and override the run method. Okay. Now take a look at the signature. It is very, very important. The run method signature is, it does not take any argument and it does not have any return type. It does not take any argument. It does not have any return type. Keep that in mind. So run method is something like a hook where you go and write your code, and your system, the JVM, or your JVM system, I would say, will ensure the code that you placed, the Java system, the code that you placed will get executed on a different thread. That's what it guarantees. So whatever piece of code that you wrote here, only this piece of code gets executed on a different thread. Only these two, only this piece of code gets executed on a different thread. All right. So creating a thread, we know that there are only two ways. One is Runnable, another is thread, and that's it. But okay, we'll come back to that. Okay. So let's take an example. What we did, and there is a myThread class. It implements Runnable, and what I'm doing is within the constructor of my class, I'm just creating an instance of new thread. Okay. And then what I'm doing is I'm just calling the thread.start. Okay. So this is the generic way of creating a thread. So what is happening? Whenever you created this, so the new thread object will get created. New thread will get created. Now, whenever new thread will get created, it needs some sort of task. It needs some sort of task that needs to be needs to be executing within this particular thread. Correct. Now, from where the task is going to be, the task will be coming from this place. So this is the task that will get executed on the new thread. And when that execution will start, the time when you are calling start method, okay? Only after this line, I would say after this line, not after, yes, after this line, new thread execution is started. Okay. Yes. Let's take a look at that. Okay. Let's take a look that from the example. Okay. So what I'm saying is, where is that? Huh. What I'm saying is, sorry, my bad. Yep. So I'm gonna implement the methods of the run. Okay. But before that, I'm gonna create the constructor for my thread. Okay. So again, my thread, I can mark it as public. Otherwise, package access is still good. And here, I want to get the instance of it. So either I can do it like thread 3 equals to new thread. I can give some name. Okay. So in thread class constructor, I can provide some name. If I do not provide the name, there could be some kind of right? Some unique name, some random name that will be assigned to this thread. Okay, so but what I'm doing is, let's say I'm just giving the name as demo thread for this guy, just like the main thread gets the main. Okay, now what we are doing is we are doing system.out.println and the sorry. Okay, so I'm gonna say that okay, this is gonna be my child thread. You can give some the same name, right? So maybe okay, let's get the uh, thread ID. Okay. Now what I'm gonna do is I'm gonna put this as a start. So what will happen? T dot start will ensure that it will go and start running the main method, and inside the main method, let's say I'm doing int I equals to 0, I less than 10 plus I, and I'm gonna do I. Okay, that's it. Right now, how this thread will get executed? How who will go and start executing this thread? So I'm gonna create the another class called main, and I'm gonna write the main method, and then I'm gonna just instantiate new my thread. That's it. All right, that's it. Now let's go and run it. Okay, let's take a brief look at it. Okay, let's take a, where is that? All right, all right, all right. Okay, so brief look at it is, let's take a look at the thread comma thread ID. Okay? All right, thread ID is gonna be Now, let's take a look at this ID. We saw that main program got the ID number 1, and then my child thread got ID number 21. Look at this, how important this is, which means there are there are 20 different threads. There are 19 different threads that got created in between this main program and the child program. So those many threads are actually created by JVM for us. Now the question is why this is not printing the I. This is not printing the numbers. Anybody wants to answer? Uh, are you still not able to see my screen? Is my screen visible? Okay. Now the question to you, all of you, is why this is not getting printed. Anyone? Why this is not getting printed? Anyone wants to answer? Yes, no? Yes, no? What's wrong with this program? What's wrong with this program? Anyone? Okay, let's take a look at that. Okay, we'll see that. Anyone? Is my screen visible? I think it got froze. Is my screen visible? Okay. So what's the reason? Oh, okay, okay. What's the reason that this is not printing anything? Anyone wants to answer, please? I want the answers. Okay, let me just run this because we are doing the thread dot start. Okay, let's go and run it. Where is that? Yep. Let's take a look at. Is the logic correct? Why it's not working? Come on. Okay. So what multi-threading does is whenever, okay, I get that. Okay, let's understand it this way. Let me remove this part. Thank you for, okay, at least I got okay. So what we'll do is, we'll do a very simplistic way, okay? So, and here, what I'm gonna do is, I'm gonna give the new of my thread. And then what I'm gonna do is, I'm gonna call start. Okay, so this is a very simplistic way. If I go and run, I'll get the output printed. Okay, clear? If I do run, I'll get an output printed. But why was the previous case not running? What we do is here. So basically what the way we need to go and create a new thread is, you go and instantiate a thread class, pass the runnable. Now runnable is either a class which implements the runnable interface, or okay, so for example, if you see my thread implements runnable, so we can say that it is implements always tells the is a relationship. So my thread is a runnable, and hence I'm just passing the, where is that? And hence I'm just passing the runnable here. So this is a runnable instance that I'm passing to a thread class, and I'm gonna call thread.start, and what it does is it will go and load the run method of this runnable class. Now let's go and create a thread a different way. Okay, so I'm gonna say that new Java class of a second thread. Okay, now if this time I want to do thread class itself, so what I'm gonna do is I'm gonna okay, extend threads, and then I'm gonna, let's say, do I need to create a constructor? No, I'm gonna say override public void run. Okay, now in this case I'm gonna just do the same thing. Okay, so all right, now let me go back to the main class. What I'll go and do is second thread. Okay, what did I get? So I have two ways to create. So one is either I go and extend thread class, or I go and implement the runnable interface. So these are the two ways to create the threads in Java. All right, clear? Now the question to you is, let's say, let me go back to this. What I'm doing is, let's uncomment this part. Anyone, I can go and uncomment this. Let's go and debug this program, and let's see when actually the thread is getting thread starts running. Okay, so let's go and debug the main program. What will happen? Yes, now I'm gonna do F7 or F8. What is that? F8, right? So okay, now at this point, if you see this thread got created. This thread got created of thread 0. There are some different things. Okay, so keep that in mind. This is not a daemon thread. Okay, and let's take a look at the thread state. Where is that? Where is that? Group we got, but no. Where is that? Stack size, thread status. Okay. So let's take a look at this guy. Okay. So which means I'm going to talk about the status. Okay. So it says that 0, right? It is an int type variable and it is initialized with just 0, which means the thread hasn't started yet. The thread hasn't started yet. We'll go and see that when we go and put the breakpoint in this guy. So in this case, thread hasn't started. I'm going to add the breakpoint here and let's take a look at the thread in what state it goes. Okay, so I'm going to say F8. Okay. Now, where is that? Did I, my thread is the my thread. I'm gonna start and then I had the run method. All right. All right. Let me go and debug again. Okay, so let's come back to this and see the thread state. Okay, so wait, where is that? This dot F8. Okay, or where is that main thread? Okay, I do not have any data points, so that's the reason. Let me just go and run that. Otherwise, will not get the, where is that? Okay, so this is thread 0. See, the state of that thread, if you see, this says that this thread has been running. Okay, so and in this case, if you go and inspect the status of that thread, that will not be 0. That's what I wanted to. So okay, so the whole idea is whenever we extend the thread class, I just go and I need to override the run method and I can just go and instantiate that and call the start method. But whenever I go and implement Runnable, I need to create a thread. I need to actually create a thread class instance and then I will be calling the start. And once the start is called, then only the thread starts running. Is it clear, everyone? Yes? Is it clear? Now, let's switch back to the board. Okay. We already saw the creates, right? Create thread runnable. And then this is also here. Okay. Now, in this case, okay, this is a different way of creating. That's completely fine. Okay. We did it right from the main method. We can do it like this also. The only thing is that we just invoke the super method, which means the thread class will get initialized. And then it will go and we are calling the start method, which means it will go and do the run. Okay, it will go and load the run method and this will start gets running. Now, in JDK 21, there is a different way. Okay, so Runnable is an interface. This is again a functional interface. So any functional interface, I can pass the lambdas. I can pass the corresponding lambdas. And if you notice, in since Java 21, there is a new way of creating the thread. It calls it as off platform. So you are doing thread dot off platform and dot start. And in this, you are passing a runnable. It will ensure your method starts getting executed. That's it. Your method starts getting executed. So this is the simplest way of creating a thread in Java 21. What it creates the platform thread. And this follows a builder pattern. This is a builder pattern. Now let's take a look at the simplest example, how simple it becomes when I start using the Java 21 thread. Now, what I have to go and write is thread dot off. Oh, okay. Is my JDK not set as 21? Java, sorry, build and where is that? Yep. Oh, why is this? Compiler, not compiler. It has to be with build tools. Okay. So I'm now selecting it to JDK 21 and that's it. Okay. Now let's get back to this guy. What I'm going to do is thread dot off platform. So this is the builder pattern that was introduced. And then I'm going to write dot start. The simple program is, okay, I can say that hello twice. That's it. This guy will create a new thread and then they will start getting executed. If you do not believe, let's go and add the thread name. Dot current thread dot get name. All right. Now I'm gonna start running it. Stop and rerun. Where is that? Uses of API. Yes. Okay. Okay. So that's completely okay. Now what I'm gonna do is, oh my God. I need to go and enable it in set language level to 19, right? So setting the, how do I set? Language level is the 21, okay? Okay. Now it should be very, very clear. Okay, so just a sec. What is that issue? Uses offset language level to, yes, that's correct. What's the issue? Okay. Now I can go and start getting executed. Main program, that was one. So this is where, and if you see, and then its thread name is actually the main one, right? So main program, it just printed one, and then hello threads was printed from the thread 0. So this is where the new thread was created. Okay. So now the off platform actually creates the platform thread. So basically this creates the platform threads. Okay. Similarly, there is a thread dot of virtual is there. Okay. And I can go and write this out. Hello. I can go and say, okay, let's go and do that and run this program. Wait. Did I save? Yes. Start what we did. What's the home? There is no harm with this, but why it is not printed? Okay, I think there is one more parameter that needs to be given, right? So thread dot of virtual, and I'm giving a runnable, and this is what runnable is, right? Then I'm giving this. Why it is not running? Oh, okay, 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 okay. Okay, so one thing what we missed, okay, one thing what we missed. Let me just set daemon as set or or actually we should just put thread dot sleep. Okay, and I'm gonna say 10 seconds. Okay, and this is again a new way of representing the numbers in Java. You can put underscore just to make it very, very clear. We made it more. Okay, so that's also acceptable. And I'm gonna put this inside a try catch. Otherwise it will go and throw exceptions, and that's it. Okay. Why did I put sleep? I'll go and tell you later. But yeah, this is where, right? So we have got hello from virtual threads. Virtual thread do not get any name, so that's still fine. Okay, because it does not get any platform threads, and hence after that there is a thread wait that is happening, and we are able to see the output. Now, even if I put a break of sleep of 1 second, still I'll see the output. The reason for that is there is a concept called a daemon thread, and virtual threads, these virtual threads are actually the daemon threads. And what exactly the daemon thread are? The daemon thread do not stop your program from completion. So if let's say you have everything else, your main thread got executed and it just have one thing left. So if your main thread had just daemon threads running, main thread can exit the program, and hence your daemon thread will left in lurch. It will not get completed. So that's where your virtual threads are by default daemon threads. And that's the reason if I do not add any instructions after the virtual threads, after this daemon thread starting, I will not get this statement printed. The reason for that is these are of daemon threads. Anybody has any questions so far? Feel free to answer. Anybody has any questions so far? Okay. Any questions you may have? So what we did, thread.off virtual will create the virtual thread. And then again, there will be some career thread who will go and execute this task. This task will be assigned to the virtual thread, sorry, the career thread. And in case of the virtual threads, you will not get a name assigned. That is another part that we got to know. Okay. All right. And what else? These are again daemon threads, and this may not stop your program from exiting. All right, just to recap, what we got so far is this is the comparison chart of all the different forms of creating those threads. So if you see, I've just used the var here, that is the latest notation. So if I do not have to reuse this variable, right? It's like I do not have to reassign this variable. I can use the type as var. Okay. Now what we are doing is off platform actually creates the thread of platform type. And this is again the builder pattern. This is the builder type of creation of the threads. Again, off virtual creates the virtual thread. This is again the builder form, and these two got introduced in JDK 21. All right. In JDK 19, it was introduced as a preview, but JDK 21, they have been pushed as a well production feature, and we can start using it. Old way of creating the threads are still there. They will still work, and they actually create the default platform threads and the constructor. Okay. All right. All right. So is it clear, everyone? I want answers. Yes, no. Is it clear, everyone? Is it clear how virtual threads run, how virtual threads are? Yes, no. Everyone, please. I want a response from everyone. Cool. Now, let's see how we can go and create the different, right, multiple threads. So the same way, I can go and instantiate the new threads. And because in my constructor, I had instantiated the thread class instances, and that's why, or if it extends the thread, then this is sufficient for initializing the thread, basically starting the thread. So 1, 2, and 3, and so on. That's it. Okay. Now, there are two different concepts that exist. Okay. Okay. Virtual thread and platform thread again. Okay. We'll come back to that, Tareen. Okay. I see you have asked it, but we'll come back to that. We'll come back to that. I think the analogy, if you just think of like this, platform threads are like your personal butler. Okay. You went to the restaurant, there is a person who is standing beside your table and he will only take orders from you. The number of orders that you keep on submitting to him, he will just ensure the order is prepared or order is brought in and order is served to you. That's it. That's what the job of platform threads. Now, if you think of it, you are a restaurant owner, you have 10 tables. And now imagine everyone needs a personal butler. How many different butlers you need to hire? 10 different butlers. Now, is it the good use of those butlers' time? The answer is no. Most of the time, those butlers will keep on just waiting to receive a new order. All right. Is it clear? Now, what exactly is the virtual thread? Imagine you have a common butler and who can take the order from anyone who places. So if you are sitting at this table, you go and place your order, somebody will come and then they will receive your order. Now these tables are, you can consider it as virtual threads. When virtual threads starts submitting a task, what will happen? There will be some server, there will be some butler, common butler who will come to you, pick up your order, and he will go and submit the order, get that order executed, get that order prepared, and he will come back and serve you. But the next time that you are going to add new order, it might not be the same guy. It might be a different butler that may come and pick up your order. And that's the job of virtual thread. It needs some sort of a courier thread to go and execute the order. That's whole. Okay. Now, there are two methods that I want to talk about. One method is called as isAlive, and then another method is join. In this case, whenever I created a new threads, all of them are platform threads. And one more thing I wanted to talk about, platform threads are non-daemon threads. Non-DAEMON threads. What do you mean by that? Whenever you created platform threads, which means your main program cannot exit without ensuring your non-daemon threads have completed the executions, and they are the daemon threads. All right. So for any non-daemon thread, we can go and make a call to that isAlive. It tells that whether that thread is alive or not, where that thread is alive or not. And then comes the join. What join tells that I want to wait for that thread to complete and then I will start executing this program. Imagine I have this piece of code, and what will happen whenever you just wrote this instruction, wrote this line, what will happen? A new thread will start getting executed, new thread will start getting executed, new thread will start executing. But after this line, your main thread will also start getting executed from this way. But if I want to wait here wait here to let these threads complete, what I'm gonna do is I can go and call, imagine this is thread T1 equals to thread T2 equals to, I need to call here T1 dot join. What will happen? My main thread will wait till T1 completes its execution. Okay, my main thread will wait till T1 completes its execution. And that's the purpose of the join function. We got introduced to these threads, that's done. Then we got to learn the basics of threads. I think threading types we discussed, but not the life cycle and the priority. We will come back to this. And then this guy and then this guy, right? Okay, cool. Okay, I think given the pace that we are going, I think locking mechanism would be slightly hard to cover today. But yep, let's see how how far we can go. Yeah. So let's move on. Let's talk about the thread concurrency. What exactly is a thread concurrency? So it is the property of executing multiple threads at the same time. It is the property of executing multiple threads at the same time. So far, what we did was we just launched multiple threads. We just launched different threads, and that's it. We did not ensure whether they are actually running at the same time. Of course, it will be running in concurrently, but we haven't ensured it in a very right manner. So that's what we are gonna see. This we have already talked about it, that thread scheduler determines which thread should be executing now. So it is the job of thread scheduler which determines. Again, in Java, thread scheduler will determine about only platform threads. It will not determine about the virtual thread uh, because thread scheduler will not even know whether there is concept of virtual threads. So virtual threads concept is inherently with the JVM. JVM ensures that any task that you submitted to virtual threads, it will just tag that virtual thread with along with the some carrier thread or platform thread, and then ultimately that task will get executed using the operating system thread. That's it. So your thread scheduler will not be knowing if there is any sort of virtual threads at all. Okay. Now, there is a default scheduling algorithm that is used by thread scheduler, that is called as round robin. What round robin does is, I'll just give you a brief example. Imagine there is a T1 thread, T2 thread, T3 thread, T4 thread. Let's say it needs 10 nanosecond, it needs 20 nanosecond, it needs 12 nanosecond, it needs 50 nanosecond. Let's say it needs that much time to complete the corresponding task. Same for T2, same for T3, same for T4. Now, if let's say time quantum, right, the unit of time that will be allocated to each thread is let's say 10 nanosecond. Time quantum is let's say 10 nanosecond. What will happen? Let's say some thread got assigned the first task. Imagine T4 got the 10-second task, right? 10-second duration. Then let's say T1 got. Now, after T4 completed one round, it will be left with just 40 nanosecond. After T1 completed one round, it will be left with just 0, which means T1 has been completed. Next, imagine the next one that got scheduled was T3, and then next one that got scheduled was T2. Now, here we are talking about all the single processor system, okay? I'm talking about all the single processor system. Okay. Now, after T3 got one time quantum, which means T3 will be executed for 10 nanoseconds. So the leftover will be 2 nanoseconds that will be left. Same for T2, it will be left with 10 nanoseconds. So what it means is that next time scheduler will try to schedule, it just knows that, okay, it just has these 3 threads available. That's it. Okay. And imagine it got T3 scheduled again. Now, do you think T3 will take 10 nanosecond completely? No. T2 will finish up within just 2 nanosecond and that's it. Remaining time will be handed over back to the CPU. So CPU now can schedule the next one that is called as either T4 or then maybe T2 and so on. So the whole idea is once the T3 is scheduled, this becomes 0. Then T4 is scheduled, this becomes 30 nanosecond. And then T2 is scheduled, this becomes 0. And now scheduler knows that I just have T4 left for scheduling. So every time it will go and schedule T4, T4, T4 and so on. And this is how the round robin works. This is how the round robin scheduling works. Clear? Now, each thread receives the equal CPU cycle that we already saw. Now, if thread's allotted time is complete, but thread hasn't finished its task, context switch occurs, correct? So the switch that we are talking about, T4 got executed, and next time T1 will run, how will T1 run? First, T4's state will get saved, and that's what we are calling it as saving the state of T4 and bringing back the state of T1. This is what is called as context switch. So context switch will be done, right? And right, this is what we are saying. Next thing, all the threads. So what we are saying is each threads here are actually stored in some sort of a queue. Each threads are stored in some sort of a queue. And they do not have any sort of, right, by default, they do not have any sort of priority. But what we can do is Java also provides a way to set the thread priority, which means I would want, maybe in our previous case, I would want always T4 to get executed first. So what I'll do, I will set the highest priority to T4. Okay. So in that case, CPU scheduler will go through the priority queue. So all the priority is implemented using priority queue. So this will be of highest priority. Then there will be another queue of lower than that. There will be another queue. There will be another queue and so on. Imagine there are some tasks. There are some tasks. Imagine there are some tasks here. Imagine there are some high priority tasks here. And then there is one task that is here. Now what will happen? This is of highest priority. Highest. This is of lowest. Now what will happen even if this thread completed its quantum, still the same thread may get scheduled because it is of the highest priority. Or maybe imagine this got completed, then the next task that may get picked up could be from the next priority, that is this guy. Okay, so the lowest priority task will get the least CPU time or will get the time after the high priority tasks have been completed. That's what the scheduler ensures. So this is some sort of, you can call it as priority queue. Okay. And if we talk about the priority queue class that is present in Java, they are internally implemented right? Their internal data structure is heap. Okay. So using heap also we can do the priority queue. That's also fine. Okay. Now, what we are saying is how do we set the priority? So what it says is a thread can interrupt another thread if it is of high priority. So imagine there is this guy that is executing. Okay, this is getting executed, but imagine a new task or new task that is created for new thread that is created of high priority. What will happen? They will come and go and interrupt the execution of this thread, and hence the state will be stored for this thread, and this guy will start execution. This is how priority queue works. This is how the high priority tasks are executed. So what happens again? These priorities can only be set for platform queue, platform threads. Because older implementation is the default platform thread implementation. So these priority can only be set for the platform threads. And these are the methods. You can go and do T dot set priority, you can go and do T dot get priority, setter and getter, and these are the priority levels. Now, by default, when you do not assign any priority, the default priority that is assigned is the normal one, and the value of that is 5. Because it takes an integer, the value of norm priority is 5, min priority is 0, and then max priority is 10. That's it. So from 0 to 10, all these priorities are assigned something of highest priority. They will be assigned the priority number as 10. The norm priority, it will be 5, and then minimum is 0. So all the platform thread, when you create it by default, it gets the normal priority, which means, and whenever you are not assigning any priority, which means all your threads will have same priority, uh, and it will be considered as a simple queue, not the priority queue. But if within your program you are setting some of the priority for any of the threads, they may interrupt the low priority thread. I'm saying may, not always necessary, but again, they may interrupt. All this will be decided by your thread scheduler. Anybody has any questions so far? Anybody has any questions so far about the priority? How do we set the priority? Whatever instance that we created, thread T equals to new thread, right? We had done, I mean, my thread. And then I can do that T dot set priority. Then I'll do thread dot max priority. Or if I want to lower the priority, that also is possible. I can go and set min priority. Okay. And so on. Then after that, I'll go and do T dot start. So once you clicked on start, after that, I mean, it is not advisable to change the priority. Okay. After that, it is not advisable to change the priority because you do not know in what state that thread is. Okay. So before you submit or before you start executing the thread, then only you go and set that priority. Is this clear for you all? All right. Okay. As I said, thread priority only changes for platform thread. Set priority has no effect for virtual thread. Okay. So for virtual thread, by default, it is 5, and nobody can change it. Okay. By default, it is 5 and nobody can change that virtual thread's priority. Okay. So which means you cannot create a virtual thread of high priority, because imagine, right? The same table example. You cannot go and have right, sit on a common table which is served by a common server, and you cannot ask him to prioritize your basically order. If you have to get your order prioritized, have the personal butler assigned. That means have the platform thread created, and what it will ensure is that your order will be prioritized. Your order will be taken care by him based on the priority that you set. Okay. So again, set priority has no effect. Even if you keep on calling the common guy, he will come one by one only. Okay. So because if he had got 5 uh, order at the same time, if there are only 2 of them, so other 3 has to wait. Other 3 has to wait, and once he goes and fulfills his order, then only the other order will be taken and then served. All right, clear? Now, this is how we set the priority. For example, thread.off platform dot priority, and this is kind of some okay. I'll talk about this example. Print inventory and the start. Okay, so let's actually see the comprehensive multi-threading example, and that will make things more clear. Okay, so all right, so what I'm gonna do is I'm sharing. All right. So what I'm gonna do is I'm gonna bring back this guy. So it is like, all right. Let me show you the example of join as well, right? So this is how. Okay. Now, hmm, let us go through the examples, right? So, for example, my thread, I just created that, or you can call it as demo. And I'm gonna call it as main. I'm gonna, let's create some, runnable. And this is how we are able to create runnable. So this is the lambda block I'm writing. If you see, and what I can do is system dot and dot println. Imagine there is a thread. I'll go and say thread dot current thread dot current thread. Imagine. Okay, let's do the print the thread. And imagine I'm saying printing. Okay. What we did, thread dot current thread will get printed. We are doing plus and then we are doing. All right. This is print. Why double quote? No need. Okay. Clear. Now let's create another inventory. Sorry, another runnable. So that is like maybe for. So I have created two runnables here. Okay. And runnables are something that will get passed to the thread dot of whatever platform that we did, or right. So let's do that. System, let's say begin execution. So till now, what I have done, I have just created the task so far. I got two tasks which can be executed. They are of runnable type. Just creation of task has been completed. Completed. Now I need to submit these tasks. How I'm gonna do that? I'm gonna do that. Let's say virtual thread. Oh, sorry, virtual thread dot of virtual dot start. Okay, let's say I did that because I know daemon threads it is, so I need to have something that is okay. Let's set that priority. Okay, uh, dot priority, and let's say priority dot sorry. Priority is something. Sorry. Let's set that priority to 10. Okay. And then I'm gonna say start, and then you start printing records. All right. Sorry. Records was printed by that guy. So printing inventory. Now, till now, what I did, I started executing one print records using the virtual thread, print inventory using platform threads, and I am able to set the priority for it. Correct? Now let's use the another default constructor thread that we used to create, correct? So, and you pass the runnable here. Now, what I'm gonna do is, and name that as a constructor thread. Name that, okay? Now, this is another one that we can use. And what we are gonna do is constructor thread dot start. Correct. So this was the default way of creating the thread class by passing runnable, and then we are calling start, which will start the run method, and run method they will go and start calling the implementation of that is there. So where is that run method defined for these runnables? Anyone? These are the block lambda, and these are just the definition of the run method. Okay, this is the simple, I would say, right, the simplistic form. Okay, so this is the like lambda block that we have written, and because it is a method which does not take any argument, so I've just written that the method which do not take any argument, and this is the method block. So this is actually essentially the run method for the runnable, that is print inventory. This is the run method for the runnable, that is print record. So same way, whenever start will be called, what will happen? Print inventories run method will start getting executed. Now, let's do that, right? So I'm gonna say that, did I add? Okay, completing and then job submission. Okay. Now let's say I'm gonna add the join of it because I'm gonna wait. So for platform thread, I'm gonna wait. I'm gonna, let's say that, okay, platform thread. Okay. Now, then I'm gonna say that the virtual thread, right? Dot join. Then I'm gonna say that constructor thread dot join, and I'll say that constructor thread. Okay. Now, okay, I'm gonna add the throws interrupted exception. Because I'm not going to handle this join part because join throws the interrupted exception. I just left it to the JVM that you go and handle it. So what I did, first I'll wait for platform thread to finish, then I'll wait for virtual thread to finish, and then I wait for the constructor thread to finish. Let's go and run this program. Let's see the execution, right? So beginning execution and then ending. So till now, all the threads were started. All of the threads were started. Okay. Now let's go and print those threads. If you see, it talks about that, okay, this is the thread ID. This is the thread ID. And this is the thread name. Okay. So this one has to be a platform thread, and sorry, what is it? Priority. This is their priority that we had set. And then this is the parent thread who actually invoked this thread. So if you see, print inventory is being done by the platform thread. Where is that print inventory? And their priority was set as 10. If you see this guy. So print inventory was done by platform thread. And if you see, this is the priority that was set. Next is the constructor thread. So constructor thread tried printing it. So print constructor thread and then start. So constructor thread start printing from the print inventory. Now platform thread finished by now. So after this platform thread finished because it was of highest priority, it got finished faster. Okay, that's what we ensure. Next, if you see the virtual thread, now the real thrill begins here. There is some pool that is created by JVM. So virtual thread, so that pool is for your all the butlers, common butlers that you want who will serve all the tables. So this is what JVM did. They will go and use the fork join pool that was created by default by the JVM, and they are gonna execute the inventory print. Okay, and this is what is printing 0, 1 and 2 because this is what I wanted to print. If you see, printing records. They started printing 0, 1, and 2. And then the last time the virtual thread completed. Okay, so virtual thread finished here. And then this message we got that constructor thread finished. So the point here is the virtual thread will receive the request. So basically the order that you placed via the common butler, they may get processed, but they may get delayed sometimes. Imagine there is a personal butler also there for some tables. They will get high priority because their in fact priority was set to the higher. Okay. And if I do not set this priority as high, okay, if I do not set this, what will happen? The order we cannot guarantee. The order we cannot guarantee. Again, why did platform thread finish first? Because we first waited for them to be finished. Until this point, this join method, till it completed, what happened? My platform thread has been terminated. It's end of life for platform thread. Then same for the virtual thread. It is end of life for them. The last one, I'm waiting for constructor thread to get finished, and that's it. Okay, so let's go and did I disable the priority? Yes. Let's go and run this program. Now the sequence that you may see might be different. The sequence that you may see might be different because what we saw here is constructor thread that got the printed first. And again, the order of them might be changing. Okay, so order of them might be changing. If you see, I will run it multiple times and order of them might be changing. You see that this is from the platform threads. Okay, then my constructor thread. All right. Anybody has any questions? Anybody has any questions? What we are saying is all these threads are running in parallel. That's why their printing of those values are actually getting interleaved. If you see, this got printed before, or sometimes this is getting printed and so on. The more tasks that we submit, the more we see that interleaving. Okay, I see the messages. Okay. Okay, cool. Now, let's take a look at the, okay. Let's take a look at the interruption. Okay, let's take a look at the interruption part. Okay, how do we write the thread interruption? How do we actually go and interrupt some of the running thread? Okay, now new project package. Yes. All right. All right. So there is a method called is interrupted. Okay, so thread dot current thread dot is interrupted. What I'm gonna do is I'm gonna, or you go and, so it will go and break the loop because this was an infinite loop. I want them to be, otherwise they will keep on running. Okay, so now what I'm gonna do is you go and let's say 1 second, or let's say you wait for 2 seconds. Okay. All right. What I'm going to do is I've got the reference of this thread. So actually, if you note here, anytime I'm just doing platform.of platform.start, the type of this variable is actually of thread type. So what I can do is I can call any method. So basically now I have handle of this guy. I can call that interrupt, actually interrupt. So what we are saying is after 2 seconds, this will go and interrupt, and I'll go and so I'm gonna exit the main thread. So let's take a look at that. What I'm trying to ensure is how the interruption happens. Now this has been, the child thread has been running in infinite loop, and once they receive the interrupt signal, what I'll do is I'll go and get this message printed, and then I will go and break this. Now when the interrupt signal will be received, so main thread will run this part, and then main thread will call thread.interrupt. And this thread refers to the child thread, and that's where the interruption will be received. Let's see that in action. Okay, so if you see child thread interrupt signal received, so let me just make that for 5 seconds. That way we'll see the delay. 1, 2, 3, 4, 5 should go and print. All right. So if you note, the child thread interruption signal got received, and that's where the main thread is exiting. Okay. So that's how these things interruption works. Okay. Now, as I said, the high priority threads, if it do not find the available execution, right, available core for its execution, it will go and interrupt the low priority threads, and that's how this is gonna happen. Okay. Now, let's come back to the a quick question for you all. Okay. You have seen the print inventory, how it is. Okay. So print inventory was, imagine this is a runnable. What exactly this run method will do? What exactly this method will do? Okay. This line will do. Anyone? What exactly this line will do? What exactly this line will answer? Anyone? Okay. So question is, will this create a new thread? Answer yes or no. Will this create a new thread? Yes or no? Yes or no? I see very few answers. Everyone, please. Will this line create a new thread? Some of you are saying no. Some of you are saying yes. Okay. The answer to that is always no. Run method, you remember, it is not called by you. You calling run method is just a simple method call. You invoking, keep that in mind, run method is a simple method call. Okay. New thread is created only using start method, and it is irrespective of which type. So if here, if you see here also I'm creating the start, calling the start method, here also I'm calling the start method. So new thread is gonna be created only using start method. You cannot create a new method, a new thread using run method. So keep that in mind. So in this case, never these new threads will never be created, and this will just execute the program running within the same method. Okay, agree? Okay, daemon thread, we already talked about it, so I'm not gonna cover. So it is a thread that will not prevent JVM from exiting when the program finishes. But virtual threads are actually always the daemon thread. So in fact, your main program will not wait for virtual threads to complete. Now the question should be, how would you ensure that always virtual thread executions are completed whenever you need? How would you ensure that? The insurance will be given by this guy. The join method, calling the join method that we saw in the example, virtual thread dot join, and that's what will give you the insurance that, okay, the virtual threads, I mean, your daemon thread will wait for the virtual thread. Sorry, platform thread will wait for the virtual thread. Now, platform threads default to non-daemon, but can be changed. Okay, can be changed. So it's like platform thread. While creating the platform thread, also we can create it as a as a daemon thread, which means, okay, where is that? There are ways. So the method name is, let me share. Let me just share my screen. If you come back to the thread demo, and if we come back to this guy of platform dot daemon, okay, I can say that daemon equals to false. Sorry, daemon equals to true. By default, it is false. And in this, I can say that daemon equals to true. Hence, by default, my program will not even wait for this thread to complete. Clear? All right. Now moving on. How the life cycles of thread look like. So whenever you do a new thread, t equals to new thread, or thread where t equals to thread dot off platform, correct? And in fact, one thing that I wanted to show, that there is a method called as unstarted. There is a method called unstarted. If I do not want this thread to start immediately, there is a method called unstarted, which means I got the task submitted, but platform thread won't start running yet. Okay. So what happens is, until and unless I go and do that platform thread dot start, until and unless I do that, this will not start running. All right. So by default, whenever you create the thread instance, what will happen? It just creates a thread in the new state. When you invoke the start method, then it goes to the runnable, and then it actually starts the running. Okay, so then it starts running or able to be run. Okay, right? Now, during execution, if it requests for some of the resource, the thread will go to the blocked state and it will wait for that request to be fulfilled. Once that is fulfilled, it will go and return the response. So it will go and once the resource is granted, it will go and resume back from the blocked state back to the runnable state, or then to the running state. Difference between runnable and running state is that it is scheduler's choice, and a scheduler will decide which thread will get executed. That's why we are saying there are two states to distinguish whether a thread is runnable or it is running. Okay, so there are scheduler to decide, a scheduler which decides which threads are running or it is in the runnable state. Okay, so the difference between runnable and running is like, when a thread is ready to be executed, it will put itself in runnable state, and when actually scheduler picks, it goes into the running state. The next state is waiting state, and another is timed waiting state. Whenever you call await, it goes to indefinite waiting state unless somebody calls an interrupt. Unless somebody calls an interrupt, this thread will go into indefinitely waiting state. Then there comes the timed waiting. What is called as timed waiting? Whenever you call a method thread.sleep, for example, I'll just share my screen. Whenever I made a call to this guy, where is that? Yeah, interruption. So whenever I made a call to interrupt, then only, sorry, timed waiting I was explaining. So whenever I make thread.sleep, it goes for a sleep, but it goes for a fixed timed interval. This is very, very important. Timed waiting is still an okay state, but if you have lot of threads are in waiting state, then that's not the desirable state. That's not the desirable state of that particular thread. Now, okay, is it clear? Is it clear? In fact, another way of what I can do is I can just mark them as thread dot current thread dot wait. Okay, and imagine there is an surround catch. Okay. Now let's say I did that, but whenever it is interrupted, and I don't need this while loop again because it will wait indefinitely. Okay. What I want is whenever this is interrupted, I'm gonna say that don't throw it, and then you just go and print sys out. Okay, and then you are gonna say that. Oh, that's it, right? So which means let's say if I go and run this program, what will happen? Where is that? Thread 0 current thread is not the owner. Is it the platform thread? Yes. Thread dot current thread dot wait. So what does it say? It says that, where is that? A legal state exception is still okay. What we are saying is at which line we got the main at this line, it says okay, current thread dot wait. Okay, so we'll do that. We'll do it differently. Don't worry, we'll do that differently. But what I wanted to show you is that whenever I apply a wait, it will be very, very indefinite. Whenever I apply a wait, it will be very, very indefinite, and it will not actually wake up until you actually interrupt or somebody interrupts your thread. Okay, so this is the not the working example. We'll get you the working example right there, but ensure that whenever you put something on indefinite wait, that's a bad example. Now, what is the reason of mentioning these threads life cycle state? What's the reason of knowing these threads life cycle state? Anyone wants to answer? What is the reason of knowing these threads life cycle state? Now, I'll tell you. If you realize your application in production is hanged, if your application in your production is hanged, how would you determine, how would you diagnose? Anybody wants to answer? Anybody wants to answer? How would you diagnose or determine whether the application has hanged? So the simplest way is to take the thread dump, what we call it as thread dump of the Java process. What you will do is any application, Java application that you are seeing that, okay, it is hanged and it is not doing the desired thing. What you should do is you should go and take the thread dump and post that in the thread dump. What will you see? You will see each thread and its state, each thread and its state, each thread and its state, and so on. All right. Now what will happen? You should always see how many threads are in which all state. How many threads? You should not see more threads in blocked state. You should not see more threads in waiting state. these two are very bad, I would say, states for the thread, because the bad state would have resulted from the bad program that somebody would have written. That is completely okay. But if your threads, you will take thread dumps, thread dumps, and you will compare how many threads are in waiting state, how many threads are in block state. Timed waiting is still okay because we know that this is incurred by thread.sleep. 1000 is still okay, 2000, whatever. If it is any thread is in timed waiting state, we know that once the timeout has happened, it will come out from that waiting state, timed waiting state. Okay, so the whole idea is we should always see, I mean, this is one of the, greatest question that is asked. If you are a Java developer, how would you debug an application that gets completely frozen? The answer should be, we'll go and take the thread dump, and then we'll go and go through the thread dump. There are thread dump analyzers, or we can actually go and go through that thread dump. It is in plain text format. We can go through that dump, and we'll be able to count how many threads are in waiting state, how many threads are in, and in fact, along with the thread, it will also give you the a stack trace of which thread or this thread is waiting at which particular line of the code. Okay, so that's what the thread dump does. Okay, I'll try to showcase you that. Let's see that. Okay, I try to showcase you that. Oh, what is it? Sorry. Let me go and say that. Okay, this will go and I'm gonna do it for this guy only, and then we'll see. All right. What I'm gonna do is I'm gonna make it for 100 seconds. Right. And how do I find the application name? Mhm. Oh, I think my screen was not visible. Let me just run the program again. My bad. I'm gonna run it because I just had the 100 seconds, right? So 100 seconds are allowed. So what I'm saying is, so I'm gonna find the Java process ID. So I'm gonna say that this was interrupt. So I'm gonna say that this is my interrupt example. This is my process ID. There is a command that comes by default, that is jstack, and we have to provide the process ID. So the default command is jstack. You give the process ID. This is 8148. And then in that, you are just saving thread dump.txt. Now let's go do the, sorry, let's save it to the thread dump, not the append. Okay. Now see this. Are you seeing this? This is your thread name and this is the thread state. It is sleeping. Correct? There are thread state in runnable state, or there is one thread that is at the waiting state. Correct? There is one thread that is at the waiting state. Yes? Yes? Now, apart from that, how many other threads that you are seeing? How many other threads that you are seeing? Okay. See, look at this. The one which are daemon threads, they are already here. If you see, there are daemon threads. Now do this, just run a quick command. So like grab daemon from this thread down, you will find and wc minus l. How many daemon threads are there? That is 11. How many threads are there in waiting state? 3. How many threads are there in timed waiting state? I think waiting also will be timed waiting. So, and so on. Now there are analyzer which is readily available. You just pass on this dump and they will analyze and give it to you. One thing that I wanted to show you is that if you see, there is a set of line that has been printed where it has been waiting. So if you see somewhere, there will be some stack trace. Okay. If you see interrupt example, lambda main interrupt example, line number 7. And this case, it is in the runnable state. Okay. Now look at priority, everything, right? So OS priority is also given, CPU and all. So how much CPU time that it has incurred and everything. Okay. Apart from that, if you see all or everywhere, if you see everywhere, you have got the line number printed. So you will get to know from the thread dump whether the threads are waiting in your program or it is waiting, right, for some other program to happen. Okay. All right. Is it interesting? Did you find this interesting? Yes, no? Let me know. All right. Okay, I think interrupts an example I already gave. How to interrupt, I already gave. If thread dot interrupted, okay, all right. The next is, okay, next we'll move slightly on the concurrency API. Okay, so in Java, imagine I have to go and create threads. So should I be managing all the threads by myself? Because the examples which I gave you, I'm the one who is creating the thread. I'm the one who is ensuring the tasks are submitted. I'm the one who is managing their life cycle, whether it is, it should be in the waiting or right, it should be in the execution or not. Okay. So we'll use concurrency API. So the Java has given actually concurrency API so that API will ensure that you are only worried about the writing the task which needs to be executed in parallel. Instead of worrying about managing the thread state, thread lifecycle, and so on, joining the threads and so on, you need to just focus on how do you get the multiple tasks executed. And for that, they have given something called as java.util.concurrent package, and they have provided something called as concurrency API. So what are those APIs? This is meant for handling complicated work of managing threads for you. So they handles the thread management part. You don't need to go and create your threads. All right. So for that, what they have given you is they have given you executor service interface. They have given you executor service interface. And what are the features? It provides you thread pooling. It provides you can do scheduling. And even if you need only a single thread, this is advisable to use the executor service. Advisable to service. All right. So just to summarize, java.util.concurrent package is provided by Java. What it gives you is that it handles the complicated work of managing the threads for you, and they just provide you the executor service interface. And these are the additional features: thread pooling and thread scheduling. Now, what exactly thread pooling is? Thread pooling is like you have created a pool of threads. Instead of creating one thread every time, you created, let's say, pool of threads and kept this pool of thread handy. All these threads are created and ready to receive the task. Any task that is submitted, some thread will get assigned and they will go start executing the task. They will start executing the task. Same, a new task is assigned, the next thread will be assigned, the same new thread task is getting, next thread will start executing. Now, what will happen after this? Once this task completes, this thread is again restored into the pool. So this thread does not get killed, it just gets back to its pool. What is the reason for it? Reason is creation or termination of thread is also a time consuming process. So why to create and terminate every time? Keep those workers handy, keep those workers available. They will receive the task, they will go and do it. Once it is done, they will come back and ready to receive another task. And that's what the job of thread pool is. Now scheduling is, in all the examples that we saw today, what we did, we just kept on starting the task just now. What if I want to start a task every day or every week, Sunday, maybe 11 a.m.? What if I wanted to create a task that should run every day, Sunday, 11 a.m.? How would I do that? The answer to that is go and use the scheduler. You go and use the scheduler for that. All right, clear? Now, let's take a look at it. How the executor service can be used. As I said, executor service is an interface. So how do we get and obtain an instance of it? How do we obtain the instance of it? So they have given the executors as a factory class. And what is the use of factory? Go and create new product. So it is responsible for creating the new single thread executor. And this is the factory method of the factory class executors. And it gives an object of type executor service. And now with the help of this service, I can go and execute the runnables. Okay. I can go and execute the runnables, keep the word and the method in mind. This is okay. This is the job of executor service interface. All right. Now let's see that in action. Okay. Let's see that in action. So what is the purpose of single thread executor? It's like, I don't need to go and create thread. I don't need to go and manage thread and so on. I'll just create an executor. I'll go and keep on executing the task, and it will ensure those tasks are executed. That's it. All right. Now, okay. So let's take a look at the command that is there. That is the execute, and it executes the task at some point in future. That's the job of runnable. Okay. It executes the task at some point in future, and it is also, that's why it is also known as fire and forget method. This execute is also called as fire and forget. Fire and forget as in you submit the task and you forget it. It will ensure, executor service will ensure it gets executed sometimes in future. Let's see that in action. Now, where is the set? I think let's get this task. Okay, so whatever we had, sorry, thread demo we had, let's get these two runnables that we had. Now what I'm gonna do is I'm gonna use, okay, I'm gonna use executor service equals to single new single thread executor. All right. Now what I'm gonna do is I'm gonna submit them. What are the tasks I'm gonna submit? So this is where I will start submitting. Service dot execute. Let's say print new records. Print. Or let's say I did that again. Now let's say we did it again. All right. Let's run this. See what all happened. See what all happened. What happened? This begin and end just submitted the runnables. And after that, it started execution. So service, again, it is a single thread executor. So what it will ensure? The first task that is submitted will get executed, then the next task, and then the next task. If I change the sequence, you will see that the order will change. And this guarantees, because it's a single thread, it guarantees you the sequencing. See, I've just done the printing inventory, and then first this is what print inventory, then the print records, then the print inventory, and then print records, and then right, this was the printed okay, before, because all these threads would have been running in, right, in parallel to the main thread. Okay, so what we are saying is this is how single thread executor works. Now, one thing that to note here is we are using in the try with resources. This syntax is try with resources. We are using something, some statement within the try. And what's the significance of it? Let's take a look at it. The contract says that try with resources can only be used for something which is auto closable. Something which is auto closable only can be used with try with resources. And that's why it is ensuring that once try block is completing here, they will go and mark that as a close, and close will actually go and do the, I would say, cleanup of all the threads that were created as part of the factory method that was used here. All right. Is everyone clear with this? Is everyone clear with this? Is everyone clear with this? Now, I wanted to show you something. Okay. I wanted to show you something. Uh, that is, take a look at here. I'm going to debug this program. I'm going to debug this program. Now, F8. Now let's take a look at this. What all we have? We have something like, so this is the executor service. I'm trying to show you how exactly its internal structure is. So executor service contains some sort of a queue. And in this case, if you see, the queue size is 3 because I have submitted only 3 tasks. I have submitted 4 tasks. Maybe one task would have been completed. We'll see that. We'll see that one task would have been completed or it would have been with somewhere. Okay. So now if you see, I have submitted 4 tasks, but there are 3 tasks that is in the queue. And there is a worker who actually executes your tasks. So with worker, there is one task that is added and you go and see that which task that worker has. You go and see that which task the worker has. All right. So this is the thread. This is the name. Where is that task? I wanted to show you the task. The first task is okay. It hasn't completed yet, so I'm gonna show you. So it's pointing to this. So this is again back. Now, exclusive owner thread is gonna be your pool one. So somewhere this should be having your task that you wanted to execute. Somewhere it should be mentioning. Let me go and change that and check that for you. So pool one thread one. Okay. Now pool one thread one is, where is that? Finalizer GVM pool one thread one, right? So pool one thread one should be having the task, or because I did not add any breakpoint, let me add that breakpoint actually. That will help us a lot more easier. So let me go and add a breakpoint to this, add a breakpoint to these runnables as well. Now let me go and run these again, debug this again. What I'm gonna do, I have got my executor service created. Go and check that. And if you see the executor service, the worker queue size is 0 and there is no task that is active. Okay, so there is no task that is with the worker. Okay, so both of them are 0. Now I will put 1 because it just has only one thread, only one worker. What will happen? It will go and put that into the workers part. Correct? The next execute that I'll go and submit, what will happen? It will go and add it to the worker queue, and all other tasks that you keep on adding, they will get added to the worker queue. Now you see all 4 out of all 4, first 3 have been submitted to the worker queue, right? First one has been submitted to the workers and next 3 has been submitted to the worker queue. Now, what will happen as and when, where is that? I should have got this one as well. Oh, okay. Lambda block, you may not get. So, okay. So by some means, I should be getting the control of it. By some means, I should be getting the control of it. And for some reason, where is that? Disconnected from the target. That's completely okay. So for some reason, we are not getting the breakpoints here, but the whole crux is that always the number of thread pool. So imagine I just change the thread pool size as new fixed thread pool, new fixed thread pool of size 2. What will happen? 2 of them will go to worker and then remaining 2 will remain with the queue. Let's see that. Now let's see this. What will happen? 2 is with the worker and 2 is with the worker queue. All right. And this is how right things work with the thread pool. Okay. Now what will happen if I go and hit next? I'll go and resume. It will go and execute all the statements that was added before. All right. Anybody has any questions so far? Anybody has any questions so far?